Welcome. I am glad you're all with us tonight. At least we have a kind of a spring night, even though it's a little bit early. We have a very special guest tonight, and I want to give him his proper introduction. I'm Scott Sayre. I'm the Chief Digital Officer here at the Corning Museum of Glass. So I want to tell you a little bit about why Yasuaki is here with us tonight. So glass in itself is a fluid, malleable material in the studio, but beyond its interaction with light, it's typically seen as a static material. Tonight's speaker, Yasuaki Kakehi, specializes in how to introduce life into physical materials like glass by using these materials as interface for play, communication, and human expression. Yasu, who is formerly trained as an engineer, applies his knowledge in the computer and material sciences to create digital works of art. The field of digital art has been around for over a half century now, but it's still relatively under-recognized. The Corning Museum of Glass being the wonderful place that it is, where we're actually working with art, science, and technologies, is a great place to bring work like Yasu's, since the museum really has a broad focus, and especially with its most recent work in specialty glass residencies and its use of digital for furthering its mission both internally and throughout the world. Yasu is a great speaker to have with us tonight. Yasuaki's presentation tonight will not solely focus on glass, but will help you rethink what's possible in activating the physical. Yasuaki is a professor in environment and information studies at Keio University, Japan, and he's currently a visiting professor in the fluid interface group at the MIT Media Lab, which is why he was close by and we were able to have the wonderful opportunity of having him with us tonight. Let's all give Yasuaki a warm of applause.
I'm sorry, so I'll keep my talk. And first of all, I'd like to introduce myself a little bit. Now I'm working at Keio University in Japan. How many people have been to Japan so far? Oh, that's nice. I'm working at Keio University, and they are the member of my research group. In 2008, I started my own research group just after I got a PhD from the University of Tokyo. And most of systems I will introduce today was conducted with these great research members, so I just introduce them. And this year, fortunately, I could get a sabbatical, so I moved to Cambridge, and I started collaboration with Professor Patty Mess at MIT Media Lab. So this time I come here from Boston. And at MIT Media Lab, I'm working to make a new kind of shape-changing material or new kind of digital fabrication tool with a great member of MIT Media Lab. And I'm also working as a media artist. In Japan, I started a small media art company with several media artists. In 2005, I started a company named Lapidus. As a media artist, we have created various kinds of interactive installations using digital technologies. And recently, we also explored the field of activities, not just only on the digital field, but also the physical world. For example, we have designed the graphic design of public space, or we have also designed the picture book for kids, or we have also created the signage in the kids' hospital or something like that. Based on digital technologies, we are just looking for the new combination of physical world and digital world through the activity as a media artist. And first of all, I'd like to show a video of our recent exhibition held at Tokyo last year. My research group at Keio University was invited to exhibition at ICC. ICC is Intercommunication Center which is one of the largest media art center in Japan. And this exhibition was 9 months exhibition. That was so long for us. So we have created 30 works for this exhibition in total. And as you see in this video, we designed various kind of physical, interactive installations, like shape changing, sculpture, or color changing, physical dot, physical display. This one is a little hard to find. That one, the small dot is levitating in the air, so we can interact with artificial bug in the physical world. This is a shape-changing sculpture as well. And we are also interested in designing new tools for creation of human beings. So we hack the property of physical materials. We have designed various kind of new tool for creation. This is new kind of compass. We can draw not only circle but also rectangular shape. This is this one. This is called on note. This is a music instrument using physical music scores. And recently we are also creating various kind of shape-changing furnitures. Or these chairs can have a memory of conversation. So we can replay the movement of chairs. Yeah. So, yeah, basically, my interest is how we can combine the physical world and the digital world, and how we can make a new interface for human to make a new experience in the physical world using digital technologies. And in 2003, I started my research, and let me show my first installation created in 2003. This is based on projection technique. So you can see the large scale of projection floor. And when the audience go inside of the projection, you can see historical, old, traditional map on the aerial image of Tokyo in this case. As you might know, these animals are indicating the direction. So according to the incoming direction, their footprint will change to these kind of unique animals. So, especially in 2000, we have created various kinds of projection-based installations, because just projecting image onto the physical floor, we can change the physical world to this kind of dynamic, interactive world very easily. I'd like to show other projection-based installations. In this exhibition, we focus on using natural material as an interface. So we collect the natural stones around the museum, and we use that as an input tool for various kinds of installations. In this piece, just touching on the stone, you can see the hidden story on the physical stone. This piece is called ishimushi. Ishi is stone, mushi is bug, creatures. So we try to convert the texture of stone to some characters projected on the wall. So if we put the stone on the box recognizes the texture of the stone. According to the pattern of the texture, the system can add additional parts onto the stone, like a creature. So through this kind of experience, we can notice the slight difference of texture from the natural materials. I'd like to show another example of projection-based installations of us. This piece is called Hana, Hana, Hana. In Japanese, Hana has two meanings. One is nose, the other one is flower. And in this piece, we have tried to visualization of smell in the air. So in this case, we put some perfume onto the wet, and according to the spread of the smell, you can see the change of projection image. That means each device can recognize change of intensity or variation of smell in this field. So you can see the smell. You can smell the image on this installation. This piece is also based on projection. So projection-based approach is very useful to make invisible things to visible, especially in the physical world. So we have created various kind of interactive installations using projectors. Just overlay the digital image. Just overlaying digital image onto the physical world. We can, design a new relationship in the physical world. Yeah, as a media artist, we have created first kind of installation as I showed in the videos. And as a researcher, as an engineer, I'm also very interested in the combination of projection and material itself. So I'd like to show several works. This work is called Through the Looking Glass. There is a normal mirror in front of the audience. This is normal mirror. But you can see totally different image in front of the mirror and inside the mirror, right? Usually you can see totally same image inside and in front of the mirror. But on this work, you can see asymmetry images. And using this system, I designed a game that users play against themselves. Here's the player. Here's another player inside the mirror, just a reflection, right? But the score is not same. 2-1. Now it's tie. And you can see the characters. It's not reflected on the mirror. So maybe it's first time for him to play against himself. The point is, this mirror is normal one. So we can see myself, how to say, as usual. And finally, he can defeat himself, or he can be defeated by himself at the same time. Yeah, he won, but he lost. Yeah, technically, we put a special display in front of the normal mirror. As you see, the horizontal display here. And we have developed a special display, which is a view-dependent display. So you can see totally different image according to the viewing angle. So I put two projectors inside of the system. And we put a special glass here so that to provide a constraint to the, how to say, diffusion angle of the light, projection light. So the light from this projector diffuses to this direction, and light from this projector is going to this direction. So we can see totally different image in front of the mirror and the inside of the mirror. It's so strange experience. But the system is so simple. So the user don't need to wear any special glass or special sensors, just play the game with themselves. So I exhibit this piece all over the world so far. At the beginning, everyone has to begin to compete. And finally, they can adjust to this strange world. I'd like to show another example. In this system, I also use a special material as a screen. So you can see projection image on the physical object placed on the tabletop. According to the movement, the projection image can also track the object. So we can see the overlapped image on the physical object. So we can change the appearance of physical objects dynamically. And we can use normal physical object as an input tool for the computer, like this. In this system, I also designed a special optical screen system to realize this kind of the special projection. There are no projectors on the top of the system. All of the projectors are installed inside of the system. But it can show the projection image on the tabletop surface and the surface of physical object placed on the tabletop at the same time. that's the technical contribution in this system. So by designing the combination of material and the projection, we can design various kind of weird experiences. In this case, we use the paper as a screen. And according to the deformation of the screen, the system can change the content of projection. So in this application, you can change the page of digital book, just like a flipping physical page like this. So yeah, as you see, the projector is a very useful tool. I have a bunch of examples using projector, but I will skip them. Yeah, as you see in the videos, projector is very useful to how to say, make the interactive experience happen in the physical world. So when there's a physical object, usually a physical object is static. It's not changing its appearance dynamically. But by using the projector, we can overlay the digital image onto the physical world. So we can design the interactive experiences on the physical world itself. If we put some sensors, according to the change of physical world, the projection is also changing. So we can design dynamic interactions in the physical world. But at the same time, there is a strong limitation of projection. We need a dark room. We need a white space. So I think the main reason most of media art pieces are still installed inside of the museum. So how we can bring this kind of interactive system to outside of the museum is currently my challenge as my research. So currently, we are thinking if the projector can change actual color of physical object, that would be great. If the projector can change the shape or size, scale of physical object, that would be also interesting. So how we can use projection, not just for illumination, but also actuation of physical world is our research interest. So I would like to show several examples to activate the physical world using projection. Oops. This work is called PVLC projector. This is not artwork. This is just a technical demo. But as you see, just pressing the small device on the tabletop, the content of LED array is changing according to the position, as you see, like a puzzle. And for this interaction, we have developed special projector called PVLC projector. We use a high-speed projector. And each pixel has the hidden information in the flickering, like this. So if the device has a photosensor underneath, it can receive hidden information from the projection. So according to the information transferred by projection, the device can change its behavior. it's a little bit technical part, so I'll skip the detail. But, oops. By using this projector, we can design various kind of interesting interactions. The left one is called Stegan sonic orbs. There's a bunch of balls with LED and some sensors. And in this work, the audience can move the balls randomly on the plate. But you can see the concrete image. It's 3, 4, 5. All of the balls are moving randomly, but it can shape the concrete image on the balls. In this work, we use the special projector to send the information to all of the balls. The right one is called block cells. In this piece, we also use this special high-speed projector to control this many devices stacked on the tabletop. So the user just stack the block. It can shape this kind of animation, create this kind of animation, just stacking block on the tabletop. Technically, it's a little hard if we use sensors like a camera or something like that. So the system have to know which block is placed on which part, something like that. But in this system, projector can send all the information to the device. So it's very easy to make this interactive installation using a bunch of devices. And as one benefit, if we use projection, we can change non-electronic material to the interactive display or interfaces. This one is, in this work, we use a glass, a layer of glass. In this work, I collaborate with Tomoko Hashida, who is working at Waseda University now. And you can see kind of volumetric display on the array of glass, transparent glass. And this is also based on projection. But we can take the image. It's impossible if we use a normal projection. We can change the actual color of material using projection. You can see the technical part of this work.
Consists of two parts, a presentation part and a control part for manipulating projected ultraviolet light. The presentation part is composed of a set of transparent plates coated with photochromic material.
We use a special material which can change its color according to ultraviolet light.
Produces color under ultraviolet
and we
light,
paint the
which turns
material
natural
on the
into color
glass.
and transparent when the ultraviolet
It's
light
usually transparent, but if we project UV light on it, it can change its color like this.
the ultraviolet light source.
So we paint the material
Let's move on to
on
the
the
control part.
layer
It
of
is an
glass.
invisible projection
We
consisting
have
of
also
365
designed a special
nanometer
projector which can
ultraviolet light
project
source
UV
with a
light
digital micromirror that can control 2D invisible
like this.
patterns dynamically. We can see the pattern using a
So
paper
according to
coated by
the UV
photochromic
light, the material can change its color. So it's not a color emissive display. It's a kind of color forming
Prototype system.
display. It can change the actual color of the material.
The pattern of
So the
projected
taste,
ultraviolet light
how do you say,
controls
the
position
impression
of colors
of
three-dimensionally.
the pixel is totally different from LED type of display or just this kind of projection.
Photochromic sculpture
It's more natural.
can be changed in accordance with the projected pattern of ultraviolet
So
light.
by controlling the UV light patterns, we can change the volumetric pixels. But as you might notice, this is so slow change. So I try to make more fast volumetric display. This work is called as Transmart miniascape. Yeah, this is kind of volumetric display. And you can see the white dot on the transparent glasses. And I usually install this piece outside space. Currently, the size of this cube is 30 centimeters square. 30 centimeters of cube. So this is not so large, but it can be working as an interactive installation by connecting some sensors. By using gestures, we can change the pattern of this volumetric pixels. And yeah, last year I installed this piece at the Ars Electronica Festival. Ars Electronica is one of the largest media art festival, and I was invited to the festival, and I installed this one at Linz. So this is still installed at Ars Electronica Center. So if you have opportunity to visit Linz, you can see the actual things. And basically, this is not LED. This is not projection. We use the sunlight as a light source. So we put the special liquid crystal on a transparent glass. And I collaborate with Asahi Glass. Asahi Glass is a Japanese glass company, and to design this special panel. And we put 8 panels like this. And according to the incoming light from the sun, we can see the change of these volumetric pixels on the transparent glasses. So there is a transparent electric circuit on the surface. And by applying the voltage to each of these pixels, it can change transparency in very high speed. So we use the sunlight as a light source. So according to the weather condition, the appearance of this pixel is changing. So I think this is not a tool for watching digital images, but also this is kind of tool for noticing the slight change of physical environment. So we can notice the slight change of weather through these pixels. So when we change the location, the impression or appearance of pixels is drastically changing. So yeah, I'm now installing this piece in many venues. And technically, I also use this liquid crystal panel to other applications. This is a piece of I created this piece as commissioned work with Asahi glass. And as you see, there's the liquid crystal panel, and there is an actual physical miniature curve on the turntables. You can see the actual silhouette here, but by using the projector, you can add additional story on the actual physical object. This would be a kind of window, how to say, the shop window. So yeah, this kind of special glass has a bunch of potentials to change the physical world interaction. We have created a bunch of animations for this piece. This piece was exhibited at the business show, so it was a commissioned work. And this is based on another concept. In this work, I have tried to control the movement of physical objects by using projection-based techniques. This is artwork called Lapidus Park. As you see here, the small particle, small bug flying on the morning plate. This is not a CG, this is the actual setting. It's levitating and moving around. And we can also interact with this bug. I set a scenario that this bug likes red color. So if we project a red light on it, it will track the red object. For example, we can use real tomato, as an interface to play with this artificial bug. Yeah, through this kind of artwork, I'd like to try to make the border between the living world and in non-living material world much more, how to say, unclear. Technically, we used ultrasonic sound system to control the movement of physical particles. By generating the sound wave on the morning plate, the small particle can be trapped on the wave, and it can move around on the physical world. So in this piece, this is not based on light projection, but we use the sound projection on the physical world to change the movement of physical material. And the next one is also controlling the behavior of physical material. As you might notice, this is based on the magnetic field. By controlling the magnetic field on the stage, we can control the behavior of this magnetic creature, like this. Not just moving, but also it can control the behavior, movement. So we can design the intermaterial interactions like this. Material can move other material itself. As for the glass-based system, I also created this installation as a commissioned work. In this work, I put the thin glass here. The technically it's based on the similar system. Here is a magnet, and there is another magnet underneath that stage, so that it can control the movement of this glass. You can see. So maybe it's a fast, how to say it, of moving glasses. Yeah, and I designed several interactions with this artificial moving glass creatures. Recently, I'm also interested in the connection, how we can use the natural material as a part of interaction. The left one is using moss, living moss, as a part of physical display. When we put the water on the surface of moss, the shape of leaf will change. As you see, it's open when it's water. And if it's dried out, the leaf is closing. So by using this phenomena, we can make physical pixels, which is living in the physical world. The right one is just a work in progress project, but we try to control the movement of living fish using the visual information. We try to change the visual pattern in the side wall of this tank. According to the visual image, the living creature change its behaviors. So it could be possible to interact with living creatures using these kind of digital techniques. But now we're still looking for the good, application or so it's still ongoing. I skip this part. I'd like to show this one. As another direction, we are also interested in how we can use this kind of dynamic material for our daily life. So especially we are focusing on designing new creation tools. In this system, you can see the user is drawing on the physical paper. It looks usual situation, but actually this is semi-automatic drawing system. That means the pen can move around, automatically on the physical paper. It can assist to draw perfect circle on the paper, something like that. We can copy the same figures on the physical paper using this special pen. No, it's not a special pen, it's a usual ballpoint pen and the usual paper. As you know, there is a ferromagnetism at the tip of the ballpoint pen. So we install the magnet underneath of this table. And by controlling the position of magnet, the pen can be attracted to the magnet. So the pen can move around by itself. By using this phenomena, we can design a new function like a copy and paste of physical drawing or something like that. technically. It's so simple. There is a magnet here underneath the tabletop surface. And it's moving. The ballpoint pen can be attracted to the magnet. It's so simple. So for example, if we connect two sets of this system, we can share the same movement of pen from sender to receiver. It could be an educational tool for drawing, sketching, or it could be kind of communication tool through haptic information. This is another drawing tool. No. This is called Templar. This is also drawing tool, but there's not so much things the user have to do. The painter have to put the first, ink on this canvas. After that, the ink can move around by itself, automatically generating the image on the physical canvas. You see the ink is moving on the canvas. So all we have to do is just watching the change and decide the finishing time of the drawing. In this system, we use the ferromagnetic fluid as a painting ink, and we put the magnet underneath of the canvas so that the ink can move around by itself. We also make large scale of drawing using this technique. In this exhibition, through 3 months exhibition, gradually this, image is going to be completed. It's so hard to find the movement change, but gradually it's changing like this. So 3 months later, we can see the complete image on the campus. Yeah, we are still looking for the new potential application fields using activated material or activated tools. Recently, we're also interested in the large-scale interactions. This is work of my collaborator, Yasuaki Kakehi. This is kind of shape-changing unit, and we are now trying to make large-scale shape-changing sculptures using this kind of techniques. And we are also exploring the potential application field. For example, the left one is we started collaboration with rehabilitation hospitals, and we designed a personal rehabilitation tool with patients. The right one is the open source toolkit for creating dance performances using the physical interactive tools, as I showed today. We are now trying to apply it to this kind of creation tools. Okay, and now, today, I bring simple demos for you. This one is called Textile Toolkit. You can play with them later. This one is open source hardware, so that that everyone can create their own haptic content. Here's the small microphone, and here's the small vibrator. Then I put them onto the paper cup, and there's nothing on this cup, right? It's like a magic, and I put the marble here. It's so hard to tell what's happening on here, that we can transfer the haptic sensation from this paper cup to the another paper cup. So we can share the same haptic tactile feeling through the existing object. It's so easy to make this kind of content. So I have whole first kind of workshop with this toolkit so that everyone can make their own haptic device. This one is not just for paper cups. We can use other type of object. By attaching the device to a spoon, we can change the, the texture of food inside of our mouth. Or we can share the vibration of our throat through this kind of device. Or someone tried to make a new toys or educational tools or new kind of entertainment tools to change the texture of material or something like that. Someone tried to make a new sport using this device. And I also show another piece here. Let me show it. Yeah, here's the music score. I saw the video at the beginning of this presentation, and here's several music scores here, and this could be instruments, music instrument itself, just pressing on the table. According to the movement of the papers, we can play music. Yeah, you can play it later. Yeah, that's all of my presentation. If you are interested in the detail or further information about my research or artworks, please let me know or check our website. Thank you so much. And if you have some comments or questions, I'm very happy to take some questions.
Special glass that was used for the motion with the ultraviolet light, is that a coating on the glass or is it solid in the glass? The reception.
So you mean the glass changing its color according to the UV light? In that case, material doesn't matter, so just paint the photochromic ink on the material. So coating, yeah, that's it, yeah.
This was a fascinating presentation, so thank you so much.
Thank you.
I just wanted to know if you are working with all this cool stuff to create experiences in an application, let's say automotive or hospitality, maybe kitchen and bath, that kind of setting.
Yeah. Thank you.
Back to the photochromic UV use. You're using lanthanides for that?
Here. Could you say it again?
When you were talking about the photochromic that has activated the color, activated by UV, are you using lanthanides as your colorant?
Yeah. So we can choose color, and we can, how to say it, it takes long time to change color, but we can arrange the color pattern on the glass, so that the expressing various kind of patterns on it. Does it answer to your question?
I was really talking about the material
Material.
that was used for the colorant. Was it with lanthanides?
It's called photochromic material. It's commercially available material, so it's UV responsive material.
Yes.
Yeah.
Is it lanthanide? Heavy metal.
Can be
Is it a lanthanide, or also known as a heavy metal?
heavy. I guess so, yeah.
Thank you.
That's all.
Do you think you could make a display using a laser with cats? Have the cats
Yeah,
chase
that would
the
be very
laser
interesting
and
to
arrange
try
the
out
cats using a laser.
Yeah.
That's all I could think of when I was seeing that.
Maybe someone have tried that.
It'd be a
Yeah.
large display, but I think that.
Yeah. How we can interact with living creatures is the interesting challenge for human beings to make a new good relationship with other creatures.
My question is whether you've worked on increasing the pixel density in your kind of planes of glass that have very discrete pixels. Can you make them much denser so that it's a more realistic portrayal of some image in 3 dimensions?
If it's possible, that would be very great. But right now, there's a limitation of the panels in terms of technical. But yeah, I'd like to make it much more large scale, or I'd like to make it more, how to say that, precise to increase the number of dots. So I have to keep collaboration with material scientists or to make a new how to say, the panel itself.
So all these cool demos, where are they physically? Are they in your lab, or is there you mentioned
It depends
museum.
on project. Most of them are installed somewhere in the world, so in the museum or other shopping malls but yeah, several of them are installed in my research group in Japan or MIT Media Lab. So if you have chance to come to Japan or MIT Media Lab, I can show this kind of demo for you. Let me know.
The senses of smell, touch, feeling, light, can you help people who are deprived or need assistance to develop those senses?
Yeah, that would be interesting. That's a good question. Yeah. Of course, there's some limitation on that device. But yeah, we can explore such kind of direction of application using smell sensors or using the, how to say, conversion from smell to other modality, like smell to sound, smell to haptics, smell to light or something like that. So that's a very interesting field. Thank you.
So I noticed a couple of your pieces had sound and audio elements to it. There's the one, obviously, that you brought with you. But do you have any other projects that you've been working with that actively engage the, I guess, the user with music and interactivity in music?
Yeah. I have several projects collaborating with musicians. For example, in dance performances, I use this kind of physical interfaces as input and converting the input data to some music for the dance performances or something like that. So we can use various kind of input to generate the new music. So sometimes it's for novice users, And sometimes it can be used for the professional musicians to create a new music itself for their performances. Yeah. But I think everything could be a kind of a new instrument. So yeah, that's a very interesting field.
Do you have plans to make these devices available for people to connect better over longer distances?
Currently, it also depends on project and but I'd like to share the the recipe how to make this kind of device for everyone. So basically, I publish them as open source hardware or software. So that's my basic direction. But sometimes I collaborate with some companies to make a commercially available product. So it depends on the project.
We should probably take one last question, if there is. Is there one last question? We're good. I guess we're good. Well, thank you all for coming tonight. I really appreciate it. Yasuaki will stay up here a little bit, and if you haven't had a chance to experience one of his inventions, he'll be here to demonstrate them for a little bit. And thanks again for coming.
Thank you so much.
Thank you.